Notice the technician on the screen attempting to navigate an AI interface while physically managing a high-pressure repair. The software requires multiple manual inputs and a stable data connection, requirements that are rarely met in a high-voltage server room or a crowded factory floor. Over time, legacy procedures and disconnected systems pile up into what we call process debt. If you take an intelligent automation tool and place it on top of these flawed steps, the software simply executes inefficient logic at a much higher speed. To successfully scale these tools, we must first map the physical reality of the field and then rebuild the workflow step by step to match how work actually succeeds under pressure. Bridging this gap is a challenge of workflow redesign. It relies on aligning the software's logic with the operational physics of the front line. This process selection checklist highlights the need to target tasks with high daily frequency. We are looking for the repetitive, high-friction workflows that define the technician's shift, rather than rare compliance audits or annual inspections. Management typically understands work as imagined, the idealized, linear process found in manuals. But the frontline survives through work as done, a series of adaptations to interruptions, missing data, and time pressure. To see this reality, you must first establish a blame-free zone. Ensure the team knows you are auditing the process, not their performance, so they feel safe demonstrating their actual habits. Observing work without the threat of punishment reveals the unofficial workarounds that currently keep the operation running. We capture these habits through a day-in-the-life observation, or DILO. During the shadow shift, the primary rule is silence. You observe the technician's actions without correcting them or offering advice. Track exactly where the technician pauses. Document every time they switch devices, search for a manual, or call a peer to fill in missing information. This DILO friction log captures friction sparks. These are the specific micro-moments where the official tool is too slow or too complex, forcing the technician to bypass the system to get the job done. These workarounds should not be viewed as non-compliance. They are clear evidence of expert adaptation to tools that are not optimized for the moment of work. A successful DILO provides a raw blueprint of the gaps between the official software and the practical requirements of the field. This split screen shows the distance between theory and reality. On the left is the 3-step process described in the SOP. On the right is the 15-step map we actually observed in the field. The difference between these two models is the debt delta. It is the measurable amount of extra effort required to complete a task because the official system is out of sync with reality. We quantify this debt by tallying duplicate data entries, the number of separate systems a technician must touch, and the total minutes lost to manual workarounds. When this debt accumulates, it creates a high cognitive load. The worker spends more energy navigating the administration of the job than solving the technical problem at hand. Presenting these figures to leadership demonstrates that applying AI to the current workflow would only scale existing inefficiencies. Before introducing new tools, we must rectify the workflow. Redesigning the process ensures that we aren't just digitizing waste. We use a 4-step sieve to clean the path. First, we eliminate steps that provide no operational value. Second, we automate routine tasks, like GPS-based site arrival, that don't require human judgment. Third, we collapse multiple forms into single, unified actions. Finally, we guide the technician by pushing only the relevant information needed for the next step. This results in a standard of care, a simplified workflow stripped of the friction that typically slows down frontline execution. This simplified foundation allows AI to act as an accelerator for the technician, rather than an additional layer of administrative work. With a clean workflow, we can map AI capabilities to the specific moment of work. We use technology to solve for speed and accuracy where it matters most. In this example, the technician scans a boilerplate, and the system instantly extracts the serial number and maintenance history. Compliance requirements are met automatically, without the technician having to type a single field. This push-based model provides the correct schematic or fault code exactly when it's needed, removing the need for the technician to stop work and search for answers. Applying AI to this optimized path allows the system to function as a background utility, handling data extraction and next-step guidance without adding manual steps to the technician's shift. The strategy is to simplify the work first and then scale the technology. This alignment ensures that when a technician reaches for a tool under pressure, it provides accurate data that matches the physical reality of the job. Consistent reliability at the moment of work ensures the technology is actually used rather than bypassed. Success should be measured by experiential metrics, such as user trust scores and the reduction of decision cycle time. To begin mapping your own frontline reality, download the DILO toolkit from the link in the description. Start your first shadow shift today.
For more insights, subscribe to Purposeful Nudge and start rewiring your field services organization today.